The only way that the laws of nature could be explained, rather than just being some random process, is if there's a process akin to natural selection. I posited that that process has to do with black holes. As the universe evolves, the number of black holes is different in different regions of the universe. Space isn't an emergent phenomenon. So there's a role for time from the beginning of the universe. No, I don't believe in the multiverse idea. There are different regions of the universe, for sure. But the universe as a whole, to me, must be constantly undergoing change. I think dimension is a very weak concept.
Lee Smolin, one of the most radical physicists of our time, the creator of cosmological natural selection, co-founder of loop quantum gravity, a scientist who challenges the very foundations of space, time, and reality.
It's a great honor having you here. Your cosmological natural selection hypothesis suggests that universes can evolve similarly to biological organisms. Tell me something more about that idea.
Well, the way I first thought of it is as an analogy to natural selection in biology. But what I was interested in to begin with was the question of how the laws of nature come to be what they are. And I was particularly interested, I was stunned by the fact that there is no explanation for what the laws of nature are. They could be very different things as far as we know. Each choice of possible laws, of which there's a very large choice, which I'll come to in a minute, is equally viable or equally possible as far as the most fundamental laws are concerned. That is the standard model, which gives us the basic framework for the laws of nature. And then the standard model does tell us what the quarks are, or what the electrons are, but it doesn't tell us what their masses are, or what their charges are, and so forth. And when you put in parameters to parameterize all the different laws of nature, you end up having about 20 independent parameters, the laws of nature. And there's no explanation for what those 20 parameters are, or how they're chosen the way they are. But the universe is very different depending on what choices you do make. That seemed to me to be, it recalled to my mind the great American philosopher, and I'm sorry, I'll think of his name in a minute. That recalled to me the great American philosopher. That recalled to me the idea, which had been a central idea of the American pragmatists, that the laws of nature must be, that the laws we have emerge from some natural processes and then somehow are chosen. So the pragmatists stated that the laws of nature they said that if you come to a point where the laws of nature where there's no rational explanation for what the laws of nature are, it must be that there's some law that guides them through a process of evolution. Just like in biology, you come to a point where the laws of nature, the laws of biology, so-called, could be very different things, and somehow there's a process which is akin to natural selection, which chooses what the laws are. And therefore, the only way that the laws of nature could be explained, rather than just being some random process, is if there's a process akin to natural selection.
Is it physically falsifiable idea?
Yes, it is. So this was the idea of Charles Peirce, who was one of the founders of the pragmatist point of view in philosophy. And yes, you can test them the same way you can test the natural selection in biology. So let's look at how you test natural selection in biology. Let me give you a schema for how the laws of nature are worked out in biology. First, there's some process which leads to random change in the laws as they are developing. Then there's a process of selection by which certain laws are more likely to survive than other laws. And then you need some process which drives the laws strongly in one direction, and that's how you get natural selection. So in biology, we know how those things work, and it's clear that there is some mechanism of selection that acts on the laws and drives them in one direction.
What was the beginning of the laws of physics?
Well, so you need a principle which causes a variety amongst the laws, and you have different regions of space and time in which the laws develop differently. And so that's the first thing you have is you have a variety, and you have to explain how the laws tend to be more prominent in one part of the universe than another part of the universe. In astronomy or cosmology, you would imagine that the process which drives the diversity is a process which produces different laws of nature than other choices. And so I posited that process has to do with black holes, and that as the universe evolves, the number of black holes is different in different regions of the universe, because some of the quark masses, for example, might be more distributed inhomogeneously, more in one place than another place. And we wait for that process to move on and drive the universe, the universe as a whole, be more prominent in one version than another, and different versions of the laws, different possibilities for the laws, can get driven to different regions of the space-time.
And this is the proof for cosmological natural selection existence?
Well, there's no proof for it, but you see the process happening. For example, it can be that if you have a region where one quark mass is different than the other quark masses, than in the other regions, then the region which has quark masses which lead to certain processes being more prevalent than others will be, as the galaxies evolve, will become more prevalent in one region than another region. What could allow that to happen is if the laws in one region, say the strange quark, are more massive in one region than another region. And what depends on the strange quark, this is one of four of the lightest quarks. And you have a process whereby if the strange quark is below a certain amount, then you will get more black holes produced in that region. And that process will drive the processes to produce more black holes. And if you look at the rate of distribution of different masses, you'll get more light black holes in a region than another region, and you'll tend to produce more black holes. So we get a prediction, because the prediction is that there's a critical region in the space. Well, the universe should be dominated by galaxies which have less than 2 solar masses for the upper mass limit of neutron stars. Then if you can then count the different regions, you will find over time that the universe is driven to be dominated by black holes of less than 2 solar masses. Now, whether that's true or not, we don't know. But there certainly seems to be an upper mass limit of about 2 solar masses.
In Time Reborn book, you propose that time is fundamental, not emergent, which contradicts many models of modern physics. Are you referring to the fact that fundamental physics ignores time because of a dogmatic of relativity theory?
No, where this started is with the question of what is time. And I discussed that with a number of friends, and we were very puzzled about the fact that in general relativity and some of its quantum versions, there appears to be no role for time. That is, you can imagine that time is emergent in quantum general relativity. There's no, you find no place for time fundamentally, so then you have to imagine that the time is emergent, as you say, which makes no sense to me, or little sense to me. So I tried to think about for a long time how the laws could be dominated by time rather than space, for example. So, for example, many people have a vision of the universe in which there is no time. Quote, this is almost a contradiction, but my friend Carlo Rovelli, for example, expresses this very, very well, although I don't think he can be correct. What I imagined is that you get laws dominated by time, which exists for all times. So there's a role for time from the beginning of the universe. There's no role for time to be emergent. Time must exist at all times. So that's the notion of fundamental time. And we worked on that with several friends and worked on various implications of that.
Have you ever thought that time is the illusion?
No, I've never. It doesn't make any sense to me.
Can space be an emergent phenomenon?
I think space can be. I think space isn't an emergent phenomenon.
How do you reconcile non-locality with the structure of the space-time?
Well, that's a very good question, and that's one of the reasons why I think that space is emergent and time isn't, is that the laws of nature appear to be non-local. And indeed, if you want a rational account of quantum mechanics, that is, you need an account of the world in which quantum mechanics satisfies the principles of Leibniz, that the laws must be explicable at all regions, at all space-times, at all ways that the world can exist, then it seems that you're going to have an easier time explaining time as fundamental and spaces arising later, so to speak. So I can imagine a framework for laws of nature in which fundamentally you start off without space, but you start off with time, and you develop the world in a framework of time which is always active and always changing. One of the things that is central to the thought that we have been developing is that the dynamics is always dynamic. So there's no fixed laws of nature. There's no fixed laws of nature. Everything is always in evolution and change.
Don't you think that physics is in crisis because it has not made a breakthrough of the scale of the theory of relativity for decades?
If you ask, yes, for decades, if you ask why there have been, first of all, you have to notice that there have been no important breakthroughs for many years since sometime in the 1970s. And this coincides with my scientific career. So I went into a science that was rapidly evolving, in which every 20, 25 years, there were major changes in the basic ideas and the basic principles of physics. And then all of a sudden, in the middle 70s, that growth process and process of change just seems to have stopped. And we had then the Standard Model had been developed and invented. It's always, you always don't know whether to say that something like that has been developed or whether it's discovered or developed. But in any case, we had the Standard Model. It had these 20 parameters which were free, which had to be explained. And we couldn't. There were then a number of possibilities, proposals to explain the parameters of the Standard Model. And some of these were called supersymmetry. Some of them were called the multiverse. There were a variety of different ideas. And all of them made predictions. And none of those predictions turned out to be the case. And some people dug their heels in and insisted that nevertheless we continue with this vision of the timeless, absolute laws. And some of us began to think of whether there could be a different version, a different view of the world.
Do you believe of multiverse idea?
No, I don't believe in the multiverse idea. I believe that as the world changes, it grows. There are different regions of the universe, for sure, or probably, to be honest, probably. But the universe as a whole, to me, must be constantly undergoing change.
What is wrong with quantum mechanics?
Yes, something is missing in quantum mechanics, and that's the ability to explain the present, knowing the details of the past. That's one way to say it. Quantum mechanics starts off to be statistical. It doesn't give precise answers or explanations for how two particles will reflect off of each other if they run into each other and then separate. It only gives probabilistic predictions for what will happen then. And it doesn't give, if you have just these probabilistic laws, quantum mechanics doesn't give any explanation or calculation for what must be behind those laws. And if we believe that everything that happens in nature should be explainable, then there's something missing. Now, some of us think that there is some of us believe that there is a complete law of physics which will explain what quantum mechanics doesn't explain. Those are sometimes called hidden variable theories. And we see the problem to find those more complete laws.
Do you think that we ever unify quantum world and gravity?
Yes. I think that in loop quantum gravity we showed one way in which it could be done. And I think it can be done.
I have some question from deep inside myself.
Okay.
Do you think that is there an objective reality independent of the observer?
Yes, of the observer. Yes, I do.
What are the limits of human cognition about the reality?
I try not to worry about questions like that because I think we don't know whether some questions will ever be answered or not. I tend to talk about the existence of symmetry as an indication that there's still more to explain.
Do you think that string theory, has made any significant progress since the publication of your books, or is it still a dead end?
I don't want to say things about friends of mine or colleagues of mine against their work. We're all faced a crisis, and none of us have been able to dig ourselves out of the crisis. So it's a shared crisis, and it doesn't seem that going into the direction of string theory improves the situation, and it doesn't seem that going in the direction of loop quantum gravity or other forms of quantum gravity invented by other people. So I think it's bad, it's rude to just criticize other people when your theory has the same problems. But a thing that I think is important to say is that when string theory first emerged on the scene and began being studied, there were a number of very talented scientists who took the time to make claims for string theory, and they claim that string theory will be the unique final theory. If you know it, it will make all sorts of new predictions and resolve all the issues in the crisis. Though nobody talked about it as a crisis then, or I should say few people talked about it as a crisis then. 30 years later, and a lot of people were hired by universities on the basis of these exaggerated claims for what the findings of string theory were. And I think that there are some apologies maybe due for that, for the rude behavior when they overclaim for their theory, because they're overclaiming for the theory specific consequences for people who made other choices. A lot of people were unable to get good employment in science if they were working on something besides string theory, and that was because the people who were working on these other directions didn't go around making exaggerated claims for the results of the theories they studied, and they consequently did not impress people as much.
You mean that string theory is a beautiful mathematical construct, beautiful mathematical idea, right?
I don't think it's that beautiful. There are parts of it that are beautiful, and some ideas that came out of string theory that are beautiful or that mathematically employ certain new tools which impressed us with their elegance and so forth. But elegance turns out, or beauty turns out not to be a very important test for the correctness in explaining nature.
Do we need more mathematics in physics today?
I wouldn't put it that way. I would say that there's always room for beautiful mathematics in mathematics. I don't think you have to. I don't think that recently discovered mathematics is more beautiful than older styles of mathematics. But it's always fun to have. Look, let's all light up and just talk about. Let's have fun. Let's show each other what's exciting. It's much. I would have proposed to my friends that we spend much more time just enjoying playing with mathematics and seeing what happens.
If you could find answer for just only one fundamental question about the reality around, about the universe, what it would be?
What is time?
Do you have any proposals?
Yes. I think that time is a process which drives all the other. I think the world is always changing. There's always novelty around. And time is the process that introduces newer ideas, newer processes that can be understood and studied.
That's something more than dimension.
Yes, I think dimension is a very weak concept.
It's a revolutionary concept. Your idea is fully opposite to the most dominant models in the classical physics. So that's why I ask you deeper and deeper.
Yes, well, I think that one can imagine. I believe with Leibniz that the law which is correct will be not only an evolutionary law, but will be a law that is always changing. The universe is always can be described in deeper ways, in more fundamental ways, are often more. There's more to learn from, and I think that the right direction in science is always the direction that teaches us more.
Thank you very much for your time.
Thank you.